Morning, friends. Today we are going to talk about prime and composite numbers, and this still all have to do with factors and multiples. So you're getting pretty good at finding the factors and multiples. Now there's one more way that we are going to be able to describe those numbers, and that's going to be trying to describe them if they are a prime number or a composite number. So you might be like, what are you talking about, Mrs. Corbin? So I'm going to give you the definition first of what a prime number is and what a composite number is. And I need a question mark here because that's a question. How can you tell whether a number is a prime or a composite? And then I'm going to show you how to use the multiplication chart to help you, and a few of our helper rules, our divisibility rules. So first of all, let's talk about prime. So prime means that that number only has two factors, one and itself. So for example, so let me write that. It only has two factors, one and itself. That means that that number can only be multiplied by 1, and that's the only time that you're going to get it. For example, if we take the number 2, and we want to find our factors for 2. So I'm going to go ahead and I'm going to pull up our multiplication chart. So I can show you how to use that. Alright, so we have our multiplication chart here. So we want all the factors of 2, and we know that 1 times 2. So that's 1 and itself. So if we look on this, do we see 2 any other place? It's 1 times 2 and 2 times 1, which is the same thing. But we cannot see 2 anywhere else on here. So that means the only factors of 2 are 1 and 2. So that means 2 is a prime number. Because the only factors of 2 are 1 and 2. There's nothing else that we can multiply that's going to give us the answer of 2. Now let's look at composite. Let's box that up because that's one of our important ones. So let's do composite. Oops, I was doing uppercase. All right. Okay, so a composite has more than 2 factors. So that means that any number that has more than 1 times itself is a composite number. So for example, let's pick the number 4. Woo! My pen lid flew. Alright, so I'm using my chart if I need to. So I already know I always start off with 1 times 4. Alright, so then I go look. Oh, there's 2. There's 2 times 4. So right away, we know, we don't even have to go any further. We know that this is a composite number because it has more than 1 times itself. I don't need to find all the factors. I just need to see if it has at least one more. Then I know that 4 is a composite number because it has 4 factors. It has 1, 2, and 4. So the trick is, though, so the little numbers we can figure out, but the trick is we want to be able to do that with any number that we're given. We want to be able to find out if it's prime or composite. All right. Let's move that. out of the way. So here, I'm going to come back up here for a minute. So as we get to the bigger numbers, there's two rules that are really important to remember. So if the number is even, one of the factors is going to be 2. So if it's even right away, you know that it's going to be a composite number because it's always going to be able to be multiplied by 2. The only exception to that is the actual number 2. Any other even number is always going to be composite because it's always going to be able to be multiplied by 2 to get that answer. The next rule is that if it ends in a 0, if the ones are a 0 or a 5, it's always going to be able to be divided by 5. So that means that you know it's going to be composite because it's always going to be able to be times 5. And you're going to be able to get that answer. So these are some quick helpers to look really fast. Is it going to be a prime or composite? So if it's even, it's going to be a composite because it's going to have more than 1 times itself. If it ends in a 0 and a 5, you know that it's going to be composite because it's always going to be able to be multiplied by a 5. All right, there are a few others that we'll talk about, but they're a little bit trickier to remember. But let's practice for a few. Let's practice a few numbers. All right, so I want to know if these numbers are prime or composite. So let's go ahead. Let's do 5. Let's do 25. Let's do 16. And let's do 7. Okay, so for all of these, we know that it's always going to be we always know this. So what our question has to be to ourselves is, are there more factors? If there are more factors, then it's composite. If there are no more factors, then it's going to be prime. So we have 1 times 5 here. Now, I said if it ends in 5, it's going to be composite, but this is one of the outliers, and only because it's itself. The only thing that's going to give us 5 is times 1. There's no other time that we see 5 here. So 5 is a prime number. Just like even numbers, except for 2. This same rule here is everything that ends in a 0 or 5 except the number 5, because there's nothing else times 5, only 1 times 5 that's ever going to give me 5. Now let's go here to 25 and let's see if our rule works. So if it's by 5, that means we can be divided by 5. So let's go look. So here's 5. Sure enough, that is 5 times 5. So it already has more than 1 factor pair. So that means that this is composite. I don't have to find them all. When they ask if it's composite or prime, you just have to figure out if you can find at least 1 more, then it is composite. So now let's try 16. 6 is even. So we said if it's even, we can divide it by 2. So let's see. Let's go to 2. Do we see 16? Sure enough, it's 2 times 8. So that means that this is also composite. All right, so now let's go to 7. Is it even? Nope. Does it end in a 0 or 5? Nope. Okay, so I'm going to go look at my multiplication chart to make sure that I can't think of anything else times that's going to give me 7, only 1. So let's check. Here's 7, and the only other time I see it is it's 7 times 1 is, which is the same thing, but I do not see 7 as any of my answers through here. So that means the only factor pair is 7 times 1, so 1 in itself. So that means 7 is a prime number. So today what we're going to be practicing is identifying numbers if they're prime or composite. We're going to be using our multiplication chart to help, and we're going to be using these two rules right here to try to help us, especially when we get to our bigger numbers.